Fifth graders, lesson 1-4B is one of those math Minnesota essential lessons that is not in your math journal, but it's on the white photocopied sheets that were in your last material pickup. Today we're going to be drawing nets for three-dimensional shapes. You will need to use centimeter grid paper that I don't think I provided. So you will have to use Notability, and I will include a PDF of it so that you can download it and complete the steps using that. So let's go ahead and do a warm-up. You can just answer these out loud. Number 1, cubes are two-dimensional figures. True or false? Say it out loud. It is false. You can see the picture on the right. Think of a pair of dice. They are not flat. They are three-dimensional. Number 2, a rectangular prism has 6 faces. True or false? That is true. It has a top, a bottom. So if I can take tally marks, a top, hang on here, a top, a bottom, a left side, a right side, a front, and a back. 1, 2, 3, 4, 5, and 6. Number 3, a net for a rectangular prism has 2 triangles. True or false? That is false. Remember, a prism gets its name from the shape of its base. So this shape is a rectangular shape, and therefore it is named on that, based on that. Number 4, a triangular pyramid has 5 faces that are all triangles. True or false? Remember that a prism has 2 bases. And the name is based on the shape of its base. And a pyramid has 1 base. And again, it is named according to the shape of its base. So this one has 1, 2, 3, and then 1 in the back. It has 4 faces. So the answer to this one is false. All right, let's go ahead and find the sheets for lesson 1-4B. And you also have to find your bag of centimeter cubes from quite some time ago. Number 1, again, pause that video if needed. The directions on lesson 1-4B saying at the top, the title's Drawing Nets for Three-Dimensional Shapes. Use centimeter cubes to build the larger cubes shown here. So go ahead and do that with your centimeter cubes. You can see I did that as well. How many faces does your larger cube have? Not the individual cubes, but the larger 3x3. Think of it as if you've ever seen a Rubik's Cube. It is a 3x3x3 shape. So how many faces does it have? Well, it has a top and a bottom, a right side and a left side, and a front and a back. So go ahead on your sheet and write 6. It has 6 faces. What is the shape of each of those faces? Well, all the sides being of equal length, they are all squares. How many of each shape are there? Well, if I were to take one individual cube and just look at it, being three-dimensional, there's a top, a bottom, a left side, a right side, and a front and a back. So each individual square cube has 6 faces. Which faces are the same size and shape, if any? Well, all 6 squares are the same size and shape. The next part says follow these steps to draw a net for the larger cube. Place your larger cube in the middle of a piece of centimeter grid paper. We're going to do this in Connect Ed. Trace a base on grid lines and shade the base. Draw the remainder of the net. Imagine the shape and the number of square centimeters it will take to cover each face of the cube without overlapping. Remember to include the top face. You have graph paper that I've included quite some time ago, so you can find your graph paper, and it might not be exactly 1 centimeter by 1 centimeter by 1 centimeter by 1 centimeter, but we'll get the correct idea. So let's go ahead and find some graph paper. If you can't find it, go ahead and draw it on a sheet of paper. But that's why I hole punch everything so that you have it easily accessible to you. So if you look at our base, it is 3 by 3 centimeter cubes. That would be my base, and I'm just going to shade it in. You can shade yours in with pencil. Now, I'm going to imagine that I'm going to cut apart my cube. Remember, I know that it has 6 faces, so when I'm done, it needs to have 6 faces. So I could draw the top here, and then the sides, and then this would be the front and the top. This, and then one more. So here are my 1, 2, 3, 4, 5, 6 different faces. So that is one way that it could be cut apart. And there are several different ways. I believe there are 11 different ways that this could be configured. So if I go back to my directions, it says draw the remainder of the net. Imagine the shape and number of square centimeters it will take to cover each face of the cube without overlapping. Remember to include the top face. So it says check your net by comparing it to your answers in problem 1, then cut it out and tape the edges. If you have it on graph paper and you want to cut it out and try it, go ahead and do so. Number 4 says use centimeter cubes to build the prism shown here. So go ahead and use those cubes again. This time, we are building a 4 by 2 by 3. Here's my question. What would be the volume of this 3-dimensional shape? Remember, volume is length times width times height. So, 4 times 2 times 3 would be what? 4 times 2 is 8. 8 times 3 is 24 centimeters cubed. Okay, how many faces does your prism have? 1, and then the back, 2, left side, right side, top, and bottom. It has 6 faces. What is the shape, or what are the shapes of each of the faces? They have different lengths and widths, so these would be rectangles. How many of each shape are there? Well, there are 6 rectangles. Which faces are the same size and shape, if any? Erase some of this. So this left side and right side, which is kind of hidden, would be the same. The front and back would be the same, and the top and the bottom would be the same. So opposite sides, the faces that are opposite are the same size and shape. And here you can see the rectangular prism when it is put together, and you can see what the net looks like. Think of a net as being two-dimensional. If you were to cut it apart and lay it flat, the color-coded are the same size and same shape.